All right, let's jump right in. Today we're talking about a really fascinating new framework called CLaRa. And what it does is tackle this huge kind of hidden problem right at the very heart of how AI systems think.
When you ask an AI a question, it seems pretty simple, right? It just kind of goes out, finds the right document, and then spits back an answer. But have you ever stopped to think about how that actually works under the hood?
Well, it turns out that whole process is kind of broken. See, for the most part, the part of the AI that finds the information and the part that answers your question, they don't really talk to each other. It's like they're operating in two totally different worlds. And this gets us right to the core issue, what we can call AI's retrieval problem. There is this fundamental disconnect between the act of finding information and the act of using it to come up with a good answer. So, the technology that powers all this is called Retrieval-Augmented Generation, or RAG for short. And it's a brilliant idea, really. It lets a large language model tap into external knowledge, which is great for keeping it up to date and stopping it from just making stuff up. But the standard way we do RAG, well, that's where the trouble starts.
So here is the deal. There are two big connected problems. First, optimization. I want you to imagine a librarian who goes and gets books for you but never ever finds out if those books were actually helpful for your research. That's basically a standard RAG system. The generator, the part writing the answer, has no way to tell the retriever, hey, that last document was perfect, find more like that. There's just no feedback loop. And second, there's a huge efficiency problem. The retriever is super efficient. It uses this compact mathematical language, these things called embeddings, to find what it needs. But then, instead of passing on that clean, efficient information, it just hands over the entire, bulky, raw text. The generator then has to wade through the whole thing. It's a massive waste of time and energy. And it's all because they're speaking different languages.
And that is exactly where CLaRa comes in. The whole point is to create a shared language, a way to finally bridge that gap using something the researchers call compressed memory. The paper itself boils down their aha moment to just 3 words: shared continuous representations. This is the big idea. Instead of 2 separate systems working in isolation, CLaRa builds one unified system where both the finder and the writer speak the exact same, super efficient language. So what does this actually look like? Well, CLaRa takes a long, raw document, and instead of passing the whole thing along, it compresses it, it squishes it down into just a handful of special memory tokens. You can think of these tokens as a super dense summary that captures the absolute essence of that document. And this compressed format is what everyone in the system, both the retriever and the generator, is going to use from now on. Okay, so how on earth do you create these smart little summaries? Well, the first step is this really clever process they call Salient Compressor Pretraining, or SCP. And this is all about teaching the AI how to look at a document and figure out what really matters, what's the most important or salient information to keep.
So here's how it builds that smart compressor. The process has 4 main steps. First, it has an LLM automatically generate a bunch of question and answer pairs from the text. Second, it creates a bunch of different paraphrases of that same text. Third, it double-checks to make sure that all this new data it created actually covers the important info from the original. And then finally, it takes all this rich, salient data and uses it to train the compressor model.
And what's really clever is the mix of training data it uses. Each piece has a very specific job. You've got simple Q&As to make sure it nails individual facts. Then you have complex Q&As to teach it how to connect different ideas together. And finally, you have paraphrases to teach it how to say things efficiently with fewer words. It's this 3-pronged attack to make sure it understands what really matters in any piece of text.
Okay, so we've got our smart compressed document summaries. That's piece number 1. Now for the second part of the puzzle, and this is maybe the most important: unified training. This is where we finally get those 2 disconnected halves of the AI's brain, the retriever and the generator, to actually learn together.
CLaRa pulls this off with some serious mathematical wizardry. It uses this thing called a differentiable top K estimator. Now, you don't need to know the math, but what you do need to know is what it lets them do. Essentially, it makes the act of choosing the best documents a smooth process. And because it's smooth, the feedback from the generator, all those learning signals, can finally flow all the way back to the retriever. For the first time, it closes that broken feedback loop.
So, does it work? Let's check out a case study from the paper. They gave the model this wildly complex question. I mean, think about it. It requires multiple logical jumps. You have to figure out who Ivory Lee Brown's nephew even is, and then you have to go find his football stats for one specific season.
And this is the truly amazing part.
When the researchers peeked inside the model's brain, they found it had added its own keywords to the search, NFL and Oklahoma. Now look back at the question. Those words are not in there, but they are absolutely critical clues to finding the right answer, which is about the football player Adrian Peterson. This proves the system is actually reasoning about what it needs to find, not just blindly matching keywords. It's incredible.
So the theory is elegant, that reasoning is super impressive, but what about the hard results? Let's look at the payoff, because CLaRa somehow manages to be both more efficient and more accurate at the same time.
The numbers really do speak for themselves. In one key test, CLaRa's compression method got a massive 17.31% performance gain over another strong compression model. And get this, it did that while compressing the original text by a factor of 4. So let that sink in. It's using a fraction of the data, but getting a significantly better answer.
But honestly, this next result is even more impressive. Here, we're looking at how well CLaRa finds the right documents compared to other specialist models. Now, those other models are fully supervised. That means humans painstakingly train them, telling them exactly which documents were the right ones. But look at CLaRa. Using only the weak signal from the final answer, it just blows them out of the water. Over 96% recall. It basically taught itself to be a better retriever than the models that were explicitly taught how to do it. And that all leads to what might be the most powerful and counterintuitive conclusion from the entire paper. This is a direct quote. The researchers found that this smart compression, this act of filtering out all the irrelevant noise, can actually lead to the AI performing better than if it had just been given the full, messy, raw text to begin with. In this case, less is literally more.
And that just leaves us with this one fascinating final thought to chew on. We always hear that the path to better AI is just bigger models and more data. But CLaRa, it suggests a totally different path. What if the real breakthrough isn't just about cramming in more information, but about giving AI a better, more efficient internal language to actually reason and think with? It's a really powerful idea.